Those are legit university problems. Those, by the way, those are taken from here, ladies and gentlemen. First year textbook. You can work out with this thing. Yes, this is what they use in first year, and that's an old edition. That's the 13th edition. They started using this about 10 years ago. Now they're using the 16th edition at Western. I am only gonna give you questions from here. Yes, I'm sorry, but I had to show you really what we're gonna be dealing with. So every single question that I'm gonna try with you most of the time is gonna be from this textbook. Okay. A postal employee drives a delivery truck along the route or route shown in figure E127. All right, so determine the magnitude and direction of the resultant or the overall displacement by drawing a scale diagram. Okay, whenever they say a scale diagram, everyone, just so you know, when they say a scale diagram, that's code in university for the cosine law method. Because you need to sketch a what? You need to sketch a what? A diagram. It doesn't have to be the scale, but it needs to be a good diagram so your angles are not screwed up. Okay? So, how many vectors do I have here? Come on. How many vectors do I have here? 3. One of them is purely what? Which direction? North. Let's say north because it looks like a map. One of them is going east, and one of them is going this one. So how many vectors do we have? 3. If we're going to add all of these 3 vectors, which method should we use? 3 vectors, not 2, 3. We should use the what? We should use the, by the way, if the question doesn't tell you which method to use, you are completely free to do whichever method. Okay? So let's do this. Okay, let's go to the next slide. Come on. What's the first method? What's the first step in this method? What do? You sketch a what? You sketch a grid. Okay, so go ahead, let's sketch a grid. I think you have a blank slide. Perfect. Okay, everyone, let's sketch the grid on this side. And this is north, and this is east. Oh, actually, sorry, everyone. Question: do I need to sketch the full grid? Why? What's my first direction? North. What's my second one? What's my next one? Which quadrant? So am I gonna need this quadrant? I just this one. So everyone, let's change the diagram. Go ahead. Let's actually put this one here. Let's actually make it just the quadrant that we need. This and this. Okay, how long is my first vector? And which direction is it? 2.6 going which way? North. Okay, okay, hold on. Tell me the length. 2.6 going up. How much going this way? 4. How much going that way? Okay, so we have 2.6, 4, and 3. Okay, so I'm going to say this one is this long. This one is this long. What's my angle for the tilted one? 45. Not bad. You said 2.6 and 4. Huh? For this one? Okay. How many good vectors do I have? Good ones. By the way, just from now on, whenever I say good vector, I mean a vector that does not need to be broken down. I have 2 good vectors, and how many bad vectors? 1. Okay, let's break down that vector. How do you break down? You just put the arrows. Sorry, I mean the dashed line. Is there anything else I can add to my diagram, or should I stop there? Come on, everyone. This needs to be, again, the dialogue you have to have yourself when you solve these problems. Can I add anything to this diagram? Signs. What do you mean by sign? Yes. Come on. Which side has to be positive? North and? I don't have any battle between north and south or east and west. So go ahead, just put plus here and plus here. Okay? How many vectors do I have on the x-axis? Huh? I say 2. I have 2 vectors on the x-axis. I have this one and this one. How many vectors do I have on the y-axis? Also 2. I have this one and this one. Great. Let's start with the x-axis first. Doesn't matter which one. Okay? Delta dx equals. Okay. Does the 4 need to be broken down? Is it pointing positively? Great. So positive 4. Go ahead. Plus. Is it going to be cosine of 45 or sine of 45? Can I use sine of 45? Why? Because 45 is the only angle that has the same what? Cosine and sine. But with the way we show it, are we using a vertical angle or a horizontal angle? So that means we should use what? For the x's, you use cosine. For the y's, you use sine. Always do it that way. So plus what? Plus 3.1 cosine of 45 degrees. Who's got the full answer? Which is positive, by the way. That's cosine of 45. Okay, Ali is getting 8.76. Actually, that's impossible. Let's think of sine and cosine. What's the biggest value for any cosine? 1. What's 1 times 3.1? 3.1 plus 4. This could not be more than 7.6. Do you see what I mean? 6.19. All right, that's fine. Let's put a unit. What's the unit? Kilometers. Go ahead. Although you're not going to lose marks if you don't, as long as you remember in the final answer. Okay, delta dy. Come on. How many vectors? Yes. Exactly. Full positive 2.6 plus 3.1. How much? 4 point in kilometers. All right. What are the last 2 steps every time? What's the first one? Pythagorean. Go ahead. Delta D equals square root of 6.19 squared plus what? 4.79 squared. What's the final answer? 36 plus 5, 50. 7.83 in kilometers. How about my theta? What divides what? X divides y or y divides x? Because it's like slope. It's not just like slope, it is slope. So it's what? 4.79 divided by 6.19. What's my angle? I guarantee you my angle is less than 45 degrees. Less than 45 degrees because my y is smaller than my x. That means I'm not up, I am low. How much? 37.73, so just 7. Okay, what's my final answer? Delta D equals 7 point. Oh, is it northeast or east-north? With this method, you're always going to put the x-axis direction first and the y-axis direction second. Every time. East, north, what? Full marks. Done. That's how beautiful and quick and straightforward this method is. You are encouraged to bring these notes, these slideshows, to your open notes test. Many of your problems will be based on these. Oh, sig figs. What is sig fig situation for the whole problem? Is it 2 or 3? Are they 2 or 3? 2. By the way, if I ever publish solutions of university textbook, most of the time they would actually get to what? To 3 sig figs or to 2 decimals. Depends. But if we're keeping to that, this should be what then? 7.8, and this should be 38. to 2 sig fig. Nice. Good. Good. Okay. By the way, these are the kind of questions that Miss Musa is going to give you in the last part of vector calculus and vectors. Question just like this. Vector A, capital A with a vector sign, is in the direction 34 degrees clockwise from the what? No. From the negative y-axis. Should we use north, east, south, west now, or y and x? How many people say y and x? Definitely y and x. Go ahead. Y, x. And it's... Where's my 34? Here or here? Exactly. Right here. Okay, does this need to be broken down? Is it a tilted vector? It's a tilted. All tilted vectors need to be broken down. Any vector inside of a quadrant needs to be broken down. So let's break it down. Dot, 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 dot. Dot, dot. Okay, whatever. Sorry, say again? Okay, everyone. Sarah's asking, can you use 56? Of course you can. Remember, you can choose whichever angle you use as long as you know it goes with what? Cosine or? Doesn't matter. I'm going to stick with this one for this one. Yes, here's my vector, A. Yes, go ahead. Yes, everyone. From here to here, how much? Should I put 16 or negative 16? Okay, how many people say 16? How many people say negative 16? How many people say it doesn't matter because you have a diagram? I say that. Now, Mr. Wilkinson might disagree. He might say, you know what? No, you have to put the minus. Why? Because it's on which side? The left side. But I just interested in the magnitude for now. So if you put just 16, I'll understand. Okay? So go ahead and put just what? 16. Okay. What's the first question? What's the y component? How long is this one? Tell me, is that component adjacent to the 34 or opposite to the 34? That component. Adjacent. What do you always use when you have adjacent? Cosine. Even though it's going on which axis? Why? But because we're using which angle? The vertical angle. Do you see what I mean? Sarah's going to switch to what? You got to switch to what? You got to switch to 56 degrees, which means to you now, this will be a sine of 56. Are we going to get the exact same answer? Of course we will. Okay? So let's do this one. So A on the y equals, how long is the vector itself? Oh, it doesn't say. Ooh, that's problematic. I didn't know you have that and you have 16. How are you going to find that? Nope. Who's got away? Hold on. I can use the sine law. I can use the sine law, but I'd rather never use the sine or cosine law, guys, except if my triangle is not a right angle triangle. If it's a right angle triangle, I can use something other than the sine or the cosine law. What do we always use? So, ka, toa. Everyone, here's my angle. Do I know this much? How much is this? What do I need to know? This much. This is the opposite, and this is the what? I need to use tangent. See, this is not a physics problem. This is a pure grade 10 math problem. So katoa, yes. So everyone, instead of saying AY, I'm going to erase it. And I'm going to write what? Tan of 34. Go ahead. Tangent. This is part A. Tangent of 34. Can someone give me what's tangent of 34? To 4 digits. To 4 digits. Point what? Point something. Come on. 6, 7, 4, 5. Equals. Okay. What's my opposite according to this? My opposite is how much? 16. Actually, you know what? How about we do it this way, everyone? Maybe then it would really look like a math problem. Yes. Now it's a perfect what? Grade 10 math problem. So 16 over, can you keep calling it edge? But we have a better name. We can call it what? Instead of AX, we can call it what? Go ahead. How do you solve this? Cross multiply. There's nothing else to do. Criss cross, which means AY is going to be what? 16 divided by 0.6745. How much is that? That's about, yeah, 23. You said 0.72. It seems that I have 3 sig figs and 3 sig figs. So I should stick to 3 sig figs. So 23.7. In what unit? In meters. Now, technically, is the answer supposed to be positive or negative? Where is my AY? Is it pointing on the positive y axis or the negative? So technically, if you want to have a therefore statement, you should say what? Therefore, AY is equal to what? So I want you to just point like this and say negative 23.7. What's the magnitude of A? There are 2 ways to do this one. Who would like to suggest one? Pythagorean theorem. Of course, I have the length here, and I have the length here, or here, whatever you want to call it. What's the other method? SOHCAHTOA. But this time, I'm looking for the hypotenuse, and I have the what? And I have the opposite. So what am I going to use? Sine. Which one seems to be less work? Doing SOHCAHTOA or doing Pythagorean? Really? I would think Pythagorean. Yeah, because you're just squaring, adding, and square rooting. So let's use that. Although, what is the only bad thing that could potentially arise from using Pythagorean? What also? What if your answer here was wrong? Then your answer in the Pythagorean will also be what? Will also be wrong. Okay? I'm just saying, when you want to use something that depends on something you found, you better know that. By the way, just so you know, when I mark, if you make the correct process but base it on a wrong input, you do not lose except what? Half a mark at the end. Even though your final answer is what? Completely wrong, but you did everything right. You just based it on a wrong input at the beginning. That's it. So we're going to use Pythagorean. So c squared equals a squared plus b squared. So what do we have? 16 squared plus what? 23.7 squared. What's the final answer anyway? Come on. Come on. What do we have? Okay, Layla's getting 28 point. So 28 point. In what unit? That's how long my hypotenuse is. Done. I told you, I teach physics for you in a way to make sure that when you hit that vectors part of MCV for you, you are done. Okay? Do we have any questions so far? Okay. Let's go to the next one. Okay, everyone, what's up? Huh? Sure. Me? I born and raised. Okay. Okay. This is gonna be interesting to set up. Do you have a question or to what? Sorry. Okay. Eva. How does this problem look like? A fence post is 52 meters from where you are standing. Okay, everyone, I'm standing. There's a fence post. How far away from me? 52 meters. Okay, let's keep going. In a direction where? 37 degrees north of east, or east 37 north. Good. A second fence post is what? Is south from where I stand. What's the distance of the second post from you if the distance between the two posts is 80 meters? This seems like a weird problem to set up, but let's do it. Come on. I need to sketch a diagram. Okay, everyone. I am here. Where is the first post? It's 52 meters, but in which direction from me? Always imagine you're walking out or you're walking around with what? With a portable grid. That's you. So where would it be? Which quadrant? 1, 2, 3, or 4? Quadrant 1. Now, would the 37 be up here or below here, according to this? Yeah, because technically this is what? East of north. How much? All right. So I'm going to say from a line like this and a line like this. How long is the distance? 52. And how much is this angle? Just this? Okay. Where's my second post? Come on. Where is it exactly from me? Which means what? According to the map, just below. Do I know how far it's going to be? I don't. That's what the question is asking. But I know something else about how far some other two things are. I know how far the what? The two what? So I know how far this will be from that. How far? So I think maybe if I put it here, yeah, this will be 5280-ish. Whatever. Remember, diagram is okay. So everyone, I'm going to say right here. Oops, sorry. And we're going to connect this. Not bad. 80. Question is, how long is this? Come on. Why sine law and not cosine law? Why sine law? I know you're so fixated on the what? On the cosine law. But everyone, this actually probably cannot be done with the cosine law. You need to use the sine law. Do you have two distances given? Which angle do you have given? The angle in between or outside of them? If you had to use the cosine law, you have always, again, everyone, the cosine law works for how many cases? Two cases. Either you're given all three sides, which trust me, in physics you will never be, or you're given how many sides? Two, with the angle where? In between. Do you have the angle in between these two? No, you don't, which means the cosine law is not going to work. So what must work? The sine law. Either cosine or sine law. They were invented to complement each other. All right. Let's call it. Let's add the labels to the triangle. What should we call this? Ramadan. So R. Post 1, post 2. Let's call them what? A and B. Everyone, A and B. What does this mean? Where is small r? Small r is here. Oops, my bad. Small r is here. Where is small b? 52. Where is small a? The unknown. Okay, let's set up the sine law. What's the statement of the sine law? Come on, sine law. It's the easy one of the two. Sine A over A, sine B over B, sine, in this case, R over R. Let's put check marks. Do I know angle A? No, I don't. Do I know length A? No, I don't. Do I know angle B? No, I don't. Do I know length B? Do I know angle R? I can find it because technically this is how much? 90. Do I know length R? Okay, this is weird. I can work with this, yet I can't find this. What do you think we should do? This is got to be how many steps? 2 steps. Both done with what? With the sine law. What are we going to do first? Sorry, what are we going to find first? We're going to find what? Sine B and then angle B. And if I know R and B, then I can know what? A. And then what can I do? Cross multiply. This has to be a 2-stepper. All right. Let's do this. So, come on. First, we're going to focus on these two. Come on. Sine of B equals what? What's B? 52 equals sine of what's my angle here? The full thing. 127. Go for it. Divided by 80. Okay. In one shot, let's find the B. Sine inverse of what? Cross divide. 52 sine of 1. Go ahead. You know what to do. I'm just going to clean this up. Sine of 127 degrees, all divided by 80. Yeah. Okay, let's hear this. How big is this? Come on. Who's got this? Let's hear 2 answers. Make sure you're on degrees. You got? Sure. That kind of looks like 31. How many you got? 31.27? Great. Let's call 31.3. 31.3. What do I do with that now? Now I know this, and I know this. How do I know this? Subtract both from 180. So that means, I'm just going to point here. So A is equal to 180 degrees minus 31.3 minus 127. How much is that? 20? 21.7. And now we can do this. Now here's my question to everyone. Everyone, should I do these? Or should I do this and that? Should I combine the A fraction with the B fraction or the R fraction? Why? Because this one is fully given exactly to me. This one, I had to work on this. Yeah. So let's do sine A over A equals sine R over R. Go ahead. Sine A over A equals sine R over R means A will be what? Sorry, what do I need? Oh, I need small a. My bad. I need small a. A equals what? Come on, crisscross. This times that divided by that. So what's R? 80 sine of A, which is sine of 21.7, divided by sine of how much? What's R? 127 degrees. What's the final answer? Say again. 37.03. Anyone? In meters, of course. But let's hear a couple of confirmations. 37.03. So just 37.0. Done. This is how far the post is. Again, all of these problems are easy math. It's the setup that could completely confuse you. That, by the way, everyone, again, that's what physics is all about. Word problems. I give you words and numbers. I give you nothing else. You need to make sense of all of that using a diagram and math. Okay, next one. Okay. A dog in an open field runs 12 meters purely east, then 28 meters in a direction 50 west of north, or what? Northwest or north 50 west, yes. In what direction and how far must the dog then run to end up 10 meters south of her original starting point? What do I need first? We're going to run 12 meters this way, and then we're going to run 50. No, not 50, sorry, I mean 28. No, no, no. We want the dog to end 10 meters south. We're trying to find this one. Okay. Do you think this is easier with cosine sine law or with vector decomposition? Vector decomposition, everyone. Let's do vector decomposition. Okay. Where is my first vector? Come on. Focus. You just had lunch. Where's my second vector? So say again. Oh, yeah. Northwest. So northwest. Yeah. Oh, sorry, not here. Where's my 50? Here or here? Come on. Yes, it's northwest. West of north means northwest. So northwest. Yes. Okay. Now, question for you, everyone. We know they move this way, or it moved this way, and it moved this way. How does it have to move to end up down? Everyone, add a vector this way. Come on. Just add a vector. Go ahead. Come on. Add a vector there. Just add it there. Trust me. Just add it there. Okay. Oh, no, no. You don't even know what the angle is. You don't even know what the angle is. So make this what? What's the symbol of an angle? Theta. Now, is this a good vector or a bad vector? Bad vector, because it needs to be what? It needs to be what? Decompose. Everyone, let's decompose. Come on. Say what? Characteristic to lines. What do you mean? Well, I see lines in a different way than you do. Come on, come on, come on. Okay. Let me find what that vector is, and then I'll prove to you why it needs to be that way. Come on. I want the dog to move just from here to here eventually, just from here to here, which means what must these vectors do to each other? This one and this one and this one. They again, the dog, to someone who didn't look, started from here and ended where? Which means technically, did they move sideways? Which means what? This vector plus this vector must equal what? That vector. Okay. Do I know how long this vector is? Do I know how much is the angle? Okay. So maybe I should call it what? Call it vector A. Everyone go ahead. Call it vector A, which means this one is AX, and this one is what? Good. Uh-huh. This one? Yeah. No. No, no. Everyone, all of these, none of them is the what? None of them is the tamirs. These are the actual motions. The dog moved this way and this way, and then it had to move this way to end up right here. None of these is the 10 meters. None of these is the 10 meters. So, what did we say? These three have to what? Cancel. Okay. So, delta dx, come on, equals. That's the key. Everyone, we're going to set east to be what? West to be what? Why am I going to set positive to be south? Because I want the dog to end what? South, which means I'm going to set this one to be negative. Okay, so what do I have in the delta dx? Come on, help me out. What is this one fully? 12 with a what? With a positive. Go. Positive 12. Okay. Positive just what? You keep going. AX. Minus what? Oh, 28 sine of 50 or cosine of 50? Come on. Are you sure? Are you sure? Everyone, I want this part. This part. Is this part cosine of 50 or sine of 50? It's sine of 50 because this part is just like this one. And this one is what? Opposite. Yep. So minus 28 sine of 50. Layla, you said it. Delta dx has to be what? Delta dx has to be made 0 because the dog did not move anything sideways. So 0 equals what? 12 plus ax minus. Can someone give me what's 28 sine 50? Come on. Sorry, minus what? Yeah, 28 sine 50 is what? No, I just want this part. 21.4. Come on. Solve for ax. Come on. Solve for ax. You're going to move this one here and this one here. 9 point. Perfect. Let's do the delta dy. Come on. Delta dy. Sorry, what's what? No, what was the question? Come on. What circle? Oh, 0. Why 0? I don't want the dog to move anything on the x. I want the dog to eventually end straight down. Delta dy, come on. How many vectors do I have on the y? Just look. How many? How many vectors do I have on the y? Only what? 2. This one and this one. But this one is pointing what? Positive. And this one is pointing what? Great. So positive ay. Positive ay. Subtract what? 28. Cosine of what? Cosine of 50. What do I want my delta dy to be? Eventually, we want the dog to have moved exactly how much down? 10. Positive 10 or negative 10? Positive. That's why I made it that. So go ahead. Positive 10 equals ay minus, who's got 28 sine 50? So 18.0. Okay? Solve for ay. Come on. Just move this guy here. So what do I get? You are confused. You know why you are confused? Because every time I gave you a bunch of vectors to add, I never asked you for an unknown vector to be included, and you know the final result. You see, everyone, every time I give you a bunch of vectors to add. So you know all the inputs, right? You know all the things going into the system. This time, I only told you how many vectors of the inputs. I only gave you the 12 and the what? And the 28 with 50 degree. And then I asked you, somehow you have to add another vector to the mix called what? Called unknown A, such that when you add this guy to this guy to this guy, what do you get as an overall? Straight down. Straight down. Nothing on the x, fully down on the y. Nothing on the x, fully down on the y. So I proposed how many components? Come on, I proposed how many components? 2. A what? An ax and an ay. And I let them what? Handle all the what? All the extra weight to make sure this happens and this happens. So what does this mean? What is the third trip of the dog? The first trip was what? 12 east. The second trip was what? 28 which direction? 50 west. What's the third trip? 9.4 meters this way, and then 28 meters this way, or whatever ends up happening if you do the hypotenuse this way. If the dog moves this way, and that way, you would just see that they moved from here to here straight. That's basically it. So okay, so let's do Pythagorean. Come on. What's A? Full A. Yeah, just add the 9.4 squared to what? To the 28 squared. Come on. How much? Come on, how much? I'll take that. 29.5 meters. So the dog needs to run 25.9 feet, 29.5 meters. In which direction? Whatever direction agrees with this theta. Let's find the theta. Oh, sorry, everyone. My bad. I know I'm jumping around a lot, but because I want to cover so much with you. Should I say the theta is here or here? I know it doesn't matter, but is this a good spot to put the theta? Again, which angle do we usually like the most? Vertical angles or horizontal angles? Which one do we like to use and to get back the most? Horizontal. Where did I place my angle? Not a big fan. I should switch it to where? Everyone, sorry for that. Go ahead, put the theta here. Erase it from here. Sorry? It doesn't matter how you place it. I just need to find where the dog runs this way. Everyone, where the dog ends, is it even showing on this diagram? No, because the dog ends where? Did you even show 10 here? No, you didn't. But did you use it? That's the trick to this question. Everyone, you have to get used to this line of thinking. Propose a vector and let the math do whatever it needs to do to get you the correct numbers. Come on, what's the angle? What's tan inverse of 28 divided by 9.4? Should be a big angle. Look how big it is. 70, maybe? Say again? 71.4. The dog needs to run exactly this way as trip number 3. Trip number 3, they have to run that way. You know what? This is worth taking some time off and actually see what happens here. Everyone, check this out. Pencils down right now. Okay. I'm going to use Microsoft Word. I'm going to show you how much you can do with Microsoft Word. Okay, where's my first vector? Which way? Come on, which way? East. Okay, let's insert a vector east. Actually, it's going to be easier for me if I do it here, because I can. Okay, come on, focus with me here. Insert, shapes. Okay, here's my first vector. How long is this one? 12 meters. Where's my other one? Okay, so everyone, I'm going to copy paste this. Can someone divide 28 by 28? Yeah, it's 28. Divide 28 by 12. 24. It's going to be 2.3333. Okay, so that means what? I need to multiply the length of this guy by 2.33. Okay, you know what? Hold on one second. Can someone multiply 1.5 by 2.33? Go. 1.5 times 2.33. You should get 3.3. So 3.5. So I'm going to make this guy 3. What? I know now that if this is 12, this is 28. Do you see how I'm scaling it up? Okay, now I need to what? Rotate by how much? All the way up such that it goes 50 this way. All right, check this out. You can actually use this rotation. And where's my angle? Okay, no, I need, see, okay, look at this. What if I do 150? 150, sorry, it's, so that's 150. It used to, did it go that way? Oh, so it rotates this way. So I need to rotate how much? Negative. Check this out. Negative. Negative what? Negative, no, 90 plus 50. 140. That's it, right? No, it goes from the x-axis counterclockwise. That's the problem. You are on the other side. That's why you have to go into the second quadrant. Okay, here is my other one. Okay, Yazan, I'm trying to actually what? Create the system. Yeah, right here. Sorry. Everyone, do you agree that this is how the dog moved so far? Now I need to what? Move it this way such that it perfectly goes 10 meters this way. That's the whole idea. That's why I needed to invent a third vector. Look, everyone, I'm going to copy this and then rotate it. Just spin it. Oh, my bad. And I need to place it right here. Is this long enough? No. And extend, such that you end up perfectly where? 10 meters right here. That's my third vector. You see why it points this way now? That's what I mean by you didn't know you knew the final value. You had to invent a third player to actually give you that. That's why. Yes, that's why. It's a great time to be a physics and math student. Look what I can prove to you in 1 minute. Oh, okay. Where is the theta? Imagine there's a grid right here, Layla. Imagine there's a grid right here. I just need to know how tilted this vector is. You can tell me it's tilted from the south to the east or from the east to the south. I don't care. I just chose to what? I just chose to tilt it with this angle, not this angle. Doesn't make a difference. Okay? Okay, this one. Come on. No vectors. This is actually a pure logic problem. You normally drive on a freeway between San Diego and Los Angeles, SD and LA. At what average speed? So on average, you're going at 105 kilometers per hour, which is 65 miles per hour, and the trip takes what? 2 hours and? Okay, on a Friday afternoon, heavy traffic slows you down. To what speed? 70 kilometers per hour. How much longer does the trip take? Okay, are you still going the same distance? Did they say that you're going in different distances? No, you're still going from where? San Diego to LA. What's the equation for speed? Come on. What's the equation for speed? Yes, everyone. How many situations do I have? 2 situations. The initial situation and the final situation. So I have what? So day 1, let's write day 1. Go ahead, just write day 1. Day 1. Delta D equals what? Delta D1 equals, sorry, let's actually write the speed. My bad. Oh, what's the equation for distance? If speed is equal to distance divided by time, what's distance equal to? Speed multiplied by time. V average. Day 1 times delta time. How about day 2? Is it the same equation? Technically. But with different what? Subscripts. Which one of these 6 variables? Everyone, guys. Yazan. Which 2 of these 6 variables did not change between day 1 and day 2? Which ones? Do you see how this looks like a math problem? If the left-hand side is equal to the left-hand side, what do you say? The right-hand side must equal to the what? The right-hand side. So that means what? V times delta T for day 1 must equal what? V times delta T for day 2. So that means delta D1 is the same as delta D2. That implies V A V1 delta T1 equals V A V2 delta D2. Oh, sorry. What did I make a mistake here? I just made a very bad mistake. I put the 2 there. That makes that squared. My bad. Okay, how do I solve for this? By the way, which time do I want to find? Time in day 1 or time in day 2? Time in day 2. Let's rearrange. What do you get here? You get delta T2 equals what? All of this divided by that. So V AV1 delta T1 divided by V AV2. Okay, do we have numbers here? Do we have three numbers? Yes, we do. I have the original speed, I have the original time, and I have the new speed. But do I need to do some unit conversion? Yeah, where? Here. 2 hours and 20 minutes. I need to convert all of it to what? Hours. How much is 20 minutes out of an hour? Come on, 20 minutes out of an hour. 1/3. So that means VAV1 is 105 times 2.3333. This goes to that. Okay, come on. Who's got this? Come on. 105 times 2.33 divided by that. Come on. How many hours? We're almost done. Come on. 1 minute left. Come on. Say again. 3 point. Is the question saying how long did it take or how longer did it take? How longer. So what do you technically need to do? You need to subtract the longer time minus the what? How much is 3? Okay, 3.5 hours. Is 3 hours and how many minutes? 3 hours and 30 minutes. What was the original time? 2 hours. So how longer did it take you? 1 hour and 10 minutes. Done. That's it.